Hello mathematicians and welcome to the video for task 4. We're going to talk about finding the LCM and GCF and how do we use it. So you'll notice at the top of your notes, we're going to start with greatest common factor, GCF. Factor, smaller. We're splitting things into small parts. We need to figure out how many people we can feed and can invite to our party. We need to figure out how many people can sit per table if we only have 4 tables. We're trying to arrange or group things. So let's look at the problem before us. We see that we are talking about school lunches for field trips. So the lunch people have 24 apple slices and 30 sticks of carrots. They want to know how many lunches can we make and not have anything left over. So we're trying to split these into smaller groups. So let's start by doing the prime factorization to get our greatest common factors. So we know that 24, the GCF, I'm going to write this here so I don't forget, of 24 is 3 times 2 times 2 times 2. Always double check my math, folks. And 30, the prime factorization is 2 times 3 times 5. So now, to find the common factor, we look for the numbers that are the same in both. So I notice I have 2 and 3, and that gives me 6. Now, much like the Castleguard problems in your workbook, this is not the number of apple sticks or carrots, carrots or apples. This is the number of bags. This is what we are multiplying those by. So the 6 is telling us we can make 6 bags. Now, how do we know how many of each go in the bag? Well, we know 24 is our apple slices. We look at the factors that are left over. So we have 2 times 2. We know that equals 4. So each bag will have 4 apple slices and 5 carrot sticks, because 5 is the only thing left over. If it was 5 times 2, we would do that. But whatever factors are left over, because 6 times 4 is 24, 6 times 5 is 30. Always check your work that way. So that is when we're talking about greatest common factor. Now, let's talk about least common multiple. When we talk multiples, we're talking bigger than our original numbers. We're going to get smaller numbers. We're looking for bigger numbers. We're looking for repeating events or purchasing multiple things. When will these events happen again? When will the guards work together? When will there be a solar and a lunar eclipse in the same year? Repeating events. So, we start by listing factors or listing multiples. So pause the video, figure out our hot dog buns. They come in packs of 10, packs of 8, but actual hot dogs come in packs of 10. How many do we need to buy? We need to figure out the multiples. So pause the video, write down the prime factorization or the multiples of 8 and 10. All right, so I have listed out here, we have the list method for all the multiples of 8, 8, 16, 24, yada, yada, and 10, 10, 20, 30, 40. I have also listed the prime factorization. So let's look at the list method. We go along until we see that, oh, look, 40 and 40 and 80 and 80 appear in both lists. So our least common multiple is going to be 40, least meaning smallest. Now, we can also use prime factorization, so let's go over how to do that. So we look first for your greatest common factor, which is 2, because each of them has 2. Now, your least common multiple is going to be 2 times all the rest of the factors. So that would be 2 times 2 times 2 times 5 will equal 40. Hey, so we get the same answer no matter what method we use. Now we need to figure out how many total packages, because we know we need 40 hot dogs and buns total, but now for packages, what do we need to do? So we know 40 equals 8 buns times some number. So we know for buns, if they come 8 per pack, we are going to need 5 packages. Let me make sure we can see that. 5 packages of buns. And then for the hot dogs, they come 10 per pack. So 40 equals 10 times some number. That equals 4. So double check our work. 4 times 10 hot dogs is 40. 5 times 8 buns is 40. We've gotten the same thing. So, folks, don't forget to write your examples for your vocabulary. And until next time, happy math.